Okay, so let's talk about one of the situations in which we can use the law of cosines, or which we need to use the law of cosines, and that is where we're given a side angle side situation, such as if we're given sides B and C and angle A. So in this example, let's say that we're told side A is equal to 10. We've got side B, which is equal to 8. And we've got angle C, which we're told is 15 degrees. We're going to use the law of cosines to find side C. So that's our first task. Now, the nice thing about the law of cosines is this. Once we use the law of cosines, that's it. We use it once and then we're done. We use the law of sines after that. So let's talk about this. We would set it up so that the square of side C is equal to the sum of the squares of sides A and B minus 2 times the product of A times B times the cosine of the angle in between, that's angle C. So filling in the missing information, we would find that C squared would be equal to 8 squared plus 10 squared, well, 10 squared plus 8 squared, minus 2 times 8 times 10 times the cosine of the angle between them, 15 degrees. All right, so where does that leave us? Well, of course, if I add up my squares right here, I'm just going to run through a little bit of arithmetic. I'm going to be adding 64 plus 100 minus 160 cosine of 15 degrees, which is to say, of course, we add 164 together, but now we're going to have to find the cosine of 15 degrees and multiply that by 160. So, getting out my trusty calculator, I take the cosine of 15 degrees, I multiply that result times 160, so I'd be subtracting 154.548. Right? So C squared is equal to 164 minus 158. Whoops, 154. Let's take care of that issue. 154.55. I'll make it 0.55 right here. So that's going to give us 164 minus 154.458. 0.548. Good Lord. 164 minus 154 point, we'll go 55 right there, 9.45, so 9.45, and of course we take the square root of that number to get our length of side C, so we're going to take the square root, which is 3.07, so C would be approximately 3.07. Well, that's it. Once we've got side C, that's all we need to find the rest of the triangle, because now we can apply the law of sines. We have enough information. So we apply the law of sines, and we're going to find one of our two missing angles. My advice is always to go for the largest angle. So which is the largest angle? Well, that's right. It has to be opposite the largest side, right? If we are doing these out, remember, if we're making up that little table that we would be using to check, we now have all three sides of this triangle, and we know that side A with a length of 10 and side B with a length of 8. Now we have side C with a length of 3.07. we know that C is 15 degrees, so the next thing we should find is the largest angle. And so in this case, I'm going to set it up so that the sine of angle A, which is the largest angle here, divided by the length of its opposite side would be equal to the sine of the angle that we do know, that's 15 degrees, divided by the length of its opposite side. So, isolating sine of A right here, sine of A will equal 10 times the sine of 15 degrees divided by 3.07. And let's work out the numbers right here. We're going to take 15, take the sine of that number, multiply it by 10, divide it by 3.07, and we're going to get sine of A equal to 0.8431. Sine of A equal to 0.8431. So that means we have to take the inverse sine of that number. So the inverse sine of the ratio 0.8431 is going to give us, inverse sine, 57.46. So 57.46 degrees. Now, will that work? Well, let's see. If we have 57.46, here's what would happen. 180 degrees minus 57.46 minus 15 degrees should give us our third angle, right? So angle C would have to be, if that were the case, 180 minus 57.46 minus 15 degrees, 107.54. What's the problem with that? Well, that would make 107.54 degrees the largest angle? Well, not quite, right? The largest angle has to be here. So somewhere we made a mistake, and the angle right here that we need is this. So what we do is the following. If we find that that's not working out, this is the job of that ambiguous triangle situation, and the actual angle A will be 180 degrees minus 57.46 degrees, and that is, in fact, 180 minus 57.46, 122.54 degrees. 122.54 degrees. And let's see how that works out. If we find angle C now by taking 180 degrees, subtracting 122.54 degrees, and subtracting the additional 15 degrees, we find that our actual angle is 180 minus 122.54 minus 15, 42.46 degrees. 42.46 degrees. And that seems to fit a little bit better, because if we have side C being 42, angle C being B being 42.46 degrees, and angle A being 122.54 degrees, I can do that a little bit better here, 122.54 degrees. We can see that the largest side is now opposite the largest angle, and the smallest side is opposite the smallest angle. And so there's a reason that we wanted to do that kind of check. But we're done with this example. Another one to come.